told you that everything you see, touch, and experience is just a tiny fraction of our universe. That a mysterious force, invisible to our eyes, holds the secrets of the cosmos. Welcome to the enigma of dark matter. As we venture deeper into the realms of space, scientists around the world are designing groundbreaking experiments to uncover the nature of this mystery. What exactly is this invisible force, and why, despite never seeing it, are we so certain it exists? Or are we guided by theories guiding these experiments, suggesting that if the dark matter is of this kind, it should interact with this regular particle in this way? This rarely happens, so we have these huge experiments trying to detect dark matter particles. If that's the case, since we have 5 times as much dark matter, that means there's a ton of regular matter in this other universe. If our dark matter is their regular matter, it turns out to escape your universe and enter another one. The strength of the gravity drops off precipitously, so it has to be even stronger than just a factor of 6. It's a honking universe, and wouldn't it be weird if one day we learned we're just some small gnat among other gnats on the back of a much larger, more powerful universe, and we're just a satellite universe to it? I want that to be true, but none of my colleagues are leaning that way. So the odds-on favorite is that there's some other kind of particle family of particles that are not the electron, proton, neutron, the ones we're familiar with, that do not interact with our particles. And if they don't interact in any sort of chemical way, then light will pass through them. You know, all you'll feel is their gravity, so I don't have a problem with that. I don't think it's as fun as thinking there could be another universe. Now, the only reason why I think this is I spoke with some top folks about field theory. These are fields that generate forces on objects, essentially a concept introduced by Michael Faraday, because no one imagined describing something you can't see that has an effect on other things. Alright, so he had to invent this concept, this field concept, so he anchored it in physics speak so that we can actually calculate with them and do other things. So in field theory, apparently, light and all the forces that surround it, electromagnetic forces, cannot exit your space-time. They're trapped within it. But gravity can. Gravity can spill out of your universe and move between universes. So if that's the case, then a nearby universe in this higher dimensional construct could have gravity spilling into our universe. And there we are, mystically touching it, thinking it's a magical invisible thing when it's just real, and it's just something sitting on the outside door for many years. The cosmos was believed to be woven with threads of a mysterious substance, dark matter. Mathematical models have boldly proclaimed that a staggering 3/4 of all matter in the universe is this elusive entity hidden away, shaping the gravitational behavior of galaxies and clusters alike. But a perplexing question arises. What if dark matter, as enigmatic as it sounds, doesn't exist? A breakthrough paper, recently published in the Astrophysical Journal, brings forth this radical idea. Scientists have scrutinized the orbital speeds of distant stars, discovering minute discrepancies that shed light on an unusual gravitational effect. This effect, known as the external field effect, has been observed across over 150 galaxies. These findings point towards a modified Newtonian dynamics theory, commonly referred to as MOND. Unlike traditional concepts, which stand on the pillars set by Isaac Newton and refined by Einstein, MOND proposes a nuanced view. It suggests that gravity induces a minute acceleration, perceivable only in colossal celestial objects, rendering the necessity for dark matter obsolete. However, not everyone's on board. While MOND has indeed withstood numerous scientific evaluations, skeptics argue that certain cosmic phenomena, like the bullet cluster of colliding galaxies, remain inexplicable through it. MOND may be a minority perspective, but its predictions have consistently mirrored astronomical observations, further fueling this debate. So if dark matter is actually real, what is it? It's probably a class of particles yet to be discovered that has a very low probability of interacting with our class of particles, electrons, protons, neutrons, and even light. And so, we have our particle family, and they may be in a whole other particle family that just simply doesn't interact. But if it has mass, it will have gravity, and we see the gravity of the dark matter. That's why we're calling it dark matter. It's matter and its gravity. 85% of the universe's gravity comes from it, but it's coexisting with us by not interacting. And that sounds kind of weird, doesn't it? Envision a substance so cryptic that while influencing the vast expanses of the universe, it remains hidden from our most advanced instruments. Comprising nearly 85% of the universe's matter, dark matter doesn't emit, absorb, or reflect light. It's like the universe's silent guardian, shaping galaxies and influencing their movements, yet never making its presence directly known. While we see the gravitational effects of dark matter, from the way galaxies rotate to the lensing of light around massive objects, its very essence remains concealed. Multiple theories try to elucidate its nature. Some postulate it consists of weakly interacting massive particles or WIMPs, while others believe it could be primordial black holes or even elusive neutrinos. As we probe further, trying to comprehend its complexities, an overarching mystery looms over our understanding. Why, in this vast cosmic dance where galaxies collide and stars explode, where particles and antiparticles annihilate each other, does dark matter stand so aloof, refusing to interact with the very matter that constructs the world we know? Why doesn't it interact at all with ordinary matter? So, it's not a stretch to imagine two things not interacting. For example, why do you have windows in your home? The windows are transparent to visible light. Now, it turns out the light does interact with the window. It interacts with particles and keeps moving through coherently. But what I'm saying is you have windows that are transparent to visible light. They're not transparent to infrared. And how do I know that? Because you could take a candle or a match and light it on one side of the window and bring your hand right up to the other side of the window, and you will not feel the heat, whereas you can see the match. So the visible light comes through the window, the infrared doesn't. We live in a world of not interacting phenomena, and we exploit that fact. Why do you have a smartphone on your hip or on your desk right now? If someone's calling you, it will ring. Where did that signal come from? It came through your walls. You could be in a windowless bathroom, and your phone will ring because microwaves pass through all of that, not interacting until it hits your phone. Then it interacts. So we have built our lives to interact with and not interact with certain forms of energy, and that's all the same family of energy. Discovering dark matter remains a profound mystery in astrophysics. Neutrinos, particles that interact minimally, offer a glimpse into the possibility of other particles with even weaker interactions. Extensive experiments may be required to capture evidence of dark matter's existence. As we explore the cosmos, each discovery brings us closer to understanding this enigmatic entity. Discovering the true identity of dark matter and developing the ability to detect it could have profound implications for our understanding of the cosmos. Much like how the discovery of radio waves enabled us to capture and utilize them for various purposes, being able to detect dark matter could lead to significant advancements. Just as we transformed radio waves into music, television, and more, studying dark matter could allow us to explore its grandeur in the universe. This would undoubtedly be a beautiful endeavor,